Welcome to Student, a series of animated calculus videos that will help you prepare for the AP exam. These videos were made by students for students.
So today we will be talking about the product rule, which is when you take the derivative of two differentiable functions that are multiplied together. So the formula of the product rule is d over dx, f of x times g of x, equals f of x times g prime of x plus g of x plus f prime of x. So an easy way to remember this instead of just a bunch of letters is first d second plus second d first, otherwise known as first function, times the derivative of the second function, plus the second function times the derivative of the first function. So let's do a quick little example here. So example here, f of x equals x sine of x. Our first function would be x, and our second sine of x, and asks us to find the derivative of f of x. So you want to have your first x, the second derivative of sine x would be cosine x, and then first sine x derivative of second, which is x, would just be 1. Then you just want to simplify. This one, there isn't much simplifying to do. Just take out the 1, multiply that into sine x, and you get f prime of x equals x cosine x plus sine x. All right, here's a multiple choice example. If y equals x squared sine of 2x, then dy dx equals, so you'd start with your first d second, your first x squared, d second cosine 2x times 2. Don't forget your chain rule here, where you take the derivative of the guts, which would be 2, and plus second sine 2x, d first 2x. So you'd want to start to simplify then, bring the 2 out front, 2x squared cosine 2x, bring the 2x out front, plus 2x sine 2x, which in all reality, this is completely simplified and a correct answer, but sometimes on the AP test, they will change it up a little bit, so you look and you realize you can take a 2x out of both, so you get 2x outside of x, or parentheses x cosine 2x plus sine 2x. And as you look here on our answer selections, that is a correct answer, and our first one is not. So just be heads up on that. So next up, we got the FRQ, which our FQ states, let f be the function defined by f of x equals cosine 2x plus e to the sine x. Let g be a differentiable function. The table above also gives values of g and its derivative g prime at selected values of x. Let h be the function whose graph consisting of 5 line segments is shown in the figure above. So the question is, let m be the function defined by m of x equals g of negative 2x times h of x, and find m prime of 2. So first, you would start with your product rule, taking the derivative of m of x. So m prime of x will equal g of negative 2x first, d second h prime of x plus second h of x, d first, which is negative 2 g prime of negative 2x. And your chain rule comes into play again, where you take the derivative of the guts, which would be negative 2, and bring that out. So next you would want to plug in your variables, which m prime of 2 is going to equal g of negative 4, because negative 2 times 2, negative 4, h prime of 2 plus h of 2, negative 2, g prime of negative 4, again with that negative 2 times 2. So now you need to go ahead and find your variables to plug them in. So g of negative 4 up here, g of negative 4, x negative 4 here, g of negative 4 would be 5, h prime of 2 would be our slope at h of 2, so here's h of 2 right here, and that slope is going to be down 1 over 3, negative 1/3. h of 2 will be negative 2/3, it's about negative 2/3 right there, and then negative 2 times g prime of negative 4, which would be negative 1, as you can see here. So the number's down, negative 2 times negative 1 times negative 2/3 plus 5 times negative 1/3. Realize I have that backwards here. These first ones match up with the 5 and that, and these match up with here. But it's all the same because it's adding and multiplying as long as everything's together on the multiplication. So sorry I got that backwards, but since it is an FRQ, you do not have to simplify. This numerical answer would be correct, but if you do simplify, it would give you a -3. So that is all I have for you today. Good luck and have a good day.